going to now talk about restrictions on domain and range of trig functions. What I want to do is I want to consider, as an example, sine of theta is equal to y over r. The first thing I want to talk about is sine of theta defined as a function. From algebra, we learned that the value you plug into the function is called the input. Another name for input is the domain of the function. Whatever value you get out of the function, in this case y over r, that we call the output, also known as the range of the function. As we consider the definitions for the trig functions, in other words, sine of theta is equal to y over r, in this case, then we need to think about what values y and r could possibly be. First and foremost, for any trig function, r is always going to be greater than 0. It's not going to be a negative number. R is the distance from the understood origin out, and so in this case, r will always be a positive value. Y can be any value. In other words, it can be 0, it can be negative, it can be positive, it can be any real number that we want it to be. It's a vertical distance. Okay. As you think about sine as defined as y over r, there's two things that I'd like to think about. First of all, is there any kind of restriction on the value that we can plug in for theta? Think about your values for theta as being the location of the terminal side as you rotate an angle around. In other words, in this case, originally we could have thought about theta as being along the positive x-axis, and then when we created a triangle, it rotated up to there. The angle, I realize, is located inside that triangle, but you can think about for a second theta as being located anywhere the terminal side would fall. Is there any kind of restriction on what theta could be? To answer this, we think about what y and r could be. In other words, let's say for a second that theta is equal to 0. In other words, theta, the initial side, terminal side, would be along the positive x-axis. Well, in that case, what's the value of y? The value of y would be 0. Okay, it's a vertical distance. What's the value of r? It could be any value. Okay, any value except for 0. So there's no problem with theta equaling to 0. Think about for a second theta equal to 90 degrees. If theta were equal to 90 degrees, then y is any real number value along the positive y-axis. R is positive. Let me boil it down to this. If you think about the values that you could possibly have for theta, then it's dependent on the values of y and r. The only thing that y over r could not be was it could not be something that's undefined. Think about for a second a fraction. So let me put this as a note. When is y over r undefined? Well, y over r would be undefined when we would have some non-zero number in the numerator and then 0 in the denominator. We know that a non-zero value divided by 0 is undefined. So is it possible that r would be 0? No, it's not possible. Remember, we said that r must be greater than 0. So there is never going to be a case where I choose an angle and that particular angle gives me an r value of 0. Okay, what this means is it means that for sine of theta equaling y over r, there are no restrictions on the value that I can plug in for theta. In other words, domain, the values that I could possibly plug in to the sine function, is any real number from negative infinity to positive infinity. Those are angle measures. All right, the next thing that I would like to consider is are there any restrictions on the actual value that I get out for sine? Okay, so are there restrictions on the value of sine. Okay? To do that, I'm going to scroll back up to my picture, and I'm going to talk about the picture that I have drawn up above. All right, for just a moment, let's assume that the triangle does fall within quadrant 1, like I have the red and blue triangle drawn here in my picture. Think about for a second the values of y and r. Okay, this thing is a right triangle. For right triangles, what do I always know about the value of r as compared to the value of y? Well, r is a hypotenuse, and we know that r is always bigger than y. Okay, so that's what I'm going to write down below, is I know a fact about right triangles and the relationship between the sides. Okay, so as a fact, because this thing is a right triangle, I know that r is always going to be greater than y. Okay, now that being the case, think about how sine is defined. Sine of theta is equal to y over r. If the larger number is always on the bottom, then you would have a fractional value of a smaller number over a larger number. That being the case, then this number is going to be less than 1. However, we have the case where in the Pythagorean theorem you could actually have r equaling to y. Okay, so in that theorem it actually says that r can be greater than or equal to y. In other words, think about for just a second this situation. Let's say that I have an angle whose terminal side falls along the positive y-axis. In that case, I could, for example, say that r was equal to 1, label a point here as 0, 1, and you see that the r value is 1 and the y value is 1. In that case, this ratio would actually equal to 1. So what we find out from thinking about the relationship between r and y, then what we end up with is we end up with a restriction on the value of sine. And the restriction on the value of sine, if we think about it this way, the value of sine is y over r, and that value either has to be less than or equal to positive 1, or greater than or equal to negative 1. Alright, what I will do next is I will go and I will say similarly, the other trig functions have these particular restrictions on their domain and range. I will do that in the next video lesson.